Friday the 15th. We are picking up on our review. Yesterday we did laws of adding, subtracting, multiplying, and dividing variables. The same for radicals. We worked with exponents. What do you do with the exponents? What does a negative exponent mean? A zero exponent? Fractional exponents. Today we're going to look at factoring and graphing. Okay, what are all the ways that we can use factoring to solve things? This is an equation, and anytime you have an equation with more than one term that has an x in it, and it cannot be combined. For instance, there's an x squared term and a 7x term. There's a specific way you solve these equations. You have to set the entire thing equal to 0 and form a quadratic equation. And you're either going to factor or use the quadratic formula. If you can factor simply, then that's what you want to do, because the quadratic formula is a little drawn out. But here we can factor x squared minus 7x by taking out a what, Caleb?
A 7.
No, how about an x?
Oh, well, the answer's 7.
And if I factor out an x, because my goal is to get all my x's to the first power so that I don't have all this extra stuff. And then what we're looking at is the zero product property. It says if two or more terms are multiplied to give you 0, then one of those terms has to equal 0.
X equals 0, x equals 7.
Exactly. We don't know which one, so we assume that they are both equal to 0. So either x is 0 or this x is 7, because 7 minus 7 gives you 0.
So whatever's in the parentheses, that's the other answers?
Well, because you're taking x and setting it equal to 0, and then you're taking this and setting it equal to 0 to see what all your possible x's are.
You just change the sign?
In this specific one, yes. This is the same concept of getting restrictions on variables in the denominator. Same concept. Except this time we want it to equal 0 instead of not wanting it to. Okay. This is also a quadratic equation. You have an x squared term and you have an x term. You're going to add 11x to both sides. You have to set it equal to 0.
Put it in the center. Put in the middle term?
Yes. You can either factor or use the quadratic formula. This is a factorable trinomial. We know that the first times the last, or excuse me, these two terms have to multiply to give us 2. So there are no other options than 2 times 1. We also know that the first times the first has to give us 6. So it's either 6 times 1 or 3 times 2. But I need a combination so that when I put my outer and inner terms together, I subtract to get 11x. And if I put them this way, this gives me 12x. This gives me 1x, and 12 minus 1 is 11x.
I thought you had to do the negative 2. Wait. Never mind.
You can't factor out a 2 because 11 is an odd number. Yes, Quentin.
That was 6 in front of x squared. How did you get that 2? The first 2 and the first one?
Well, I know that these two terms, last times last, gives me this last term. They're the only factors of 2 are 2 and 1. Okay, so I started with what I absolutely positively know. And then we back to the zero product property. If two things are multiplied to give you 0, then there are 2 possible x's. In here, either x is what?
2 over 1.
Negative 2, or in this one, x is equal to
1 over 6.
positive 1/6 are your possible x's.
So it's always the negative inverse.
you're always trying to set this up in the form of a fraction and solve for x. And so the process is going to be undo whatever the addition or subtraction. So if you're adding, you're going to say, okay, minus 2, and then undo multiplication. Divide by 1. So minus 2 divide by 1. Plus 1 divide by 6. All right, and if it's not factorable, we always have the quadratic formula that we can use. Remember, the quadratic formula was negative b plus or minus the square root of b squared minus 4ac all over 2a. But to use the quadratic formula, your equation has to be in a specific order. This is standard form because a, b, and c are specific parts of that equation. A is the coefficient of x squared, b is the coefficient of x, and c is the constant term. So you still set it equal to 0, and you use your formula to figure things out.
Are we going to need another one to do the square?
You don't not, no, you don't have to use completing the square because this will work every time. Yes. Now for circles and stuff, you may leave it a little bit, but here we go. Wait. If we are going to solve try to solve this equation for x, we need to start by adding 4 to both sides. It's coming. Taking a little break. While we're waiting for my 0 to pop up. That's not factorable. There are no factors of 12 that give you 2 when you add them together. Okay? So since it's not factorable, we can use our quadratic formula. Here we go. What is A?
3.
A is 3, B is, and C is? Okay, so x therefore is equal to negative B plus or minus the square root of B squared minus 4AC all over 2A. Two squared is 4. 4 times 3 times 4 is negative 48. And when you put it together, you have a negative 44. No, that's not your answer. You can reduce, first off, you have the square root of a negative, so you have to identify this as imaginary. And 44 is 2 times 2 times 11, which means you can take out a 2. So it's negative 2 plus or minus all that over 6. Now there are 3 terms in this fraction. If all 3 coefficients can be reduced by the same factor, then you reduce all 3 of them. And they can. They can all be reduced by 2.
So the square root of what? So plus or minus the square root?
It's negative 1 plus or minus I square root of 11 over 3. You have to have this negative 1 in the front. Because it's, when 2 and 6 cancel, 2 doesn't disappear and become 0. 2 goes into 2 once, and 2 goes into 6 3 times. Exactly. Okay, and then here, this was 1. Right. Exactly. Okay? And that would be your final answer. So, solving quadratic